Hello and welcome to the GCSE Physics tutorial for topic P2 Electricity. This tutorial covers part 1 electric circuits. It also covers 3 practicals including resistance. First of all, circuit diagram symbols. Pause the tutorial now and have a look at each of these symbols. You will need to learn all of these as they may come up in the examinations. You'll also need to know these key terms throughout the whole of this topic. Current. Current is the flow of electrical charge through a circuit. Current is measured with an ammeter and the unit for current is amps or amperes with the letter A. Potential difference or voltage, that's the force that pushes the charge around the circuit. Often this comes from the battery. Potential difference is measured with a voltmeter and the unit is volts. So voltage and potential difference are the same thing, but potential difference is the terms used in the exam. Charge is measured in coulombs, and that is current times time. Resistance is anything that slows down the flow of charge, and that's measured in ohms. Ohm's law is resistance equals potential difference divided by current. You also have to be able to rearrange that equation to find out the potential difference or find out the current. If you increase the potential difference, then you'll increase the current. But if you increase the resistance, then you will decrease the current. Whenever you use an ammeter, you always place it in series, which means it's alongside the components. Whenever you use a voltmeter, you always put it in parallel to whatever you're trying to find the voltage of. So to find the voltage of this bulb, you put the voltmeter in parallel. The first practical is looking at how the effect of the length of a wire affects resistance in that wire. First of all, you set up the circuit as here, so the ammeter is in series, the voltmeter is in parallel to the wire. And then you will attach crocodile clips along this wire, so at 0 centimetres and the other crocodile clip at 10 centimetres. You'll turn it on and then you record the current and the voltage. Turn it off and then change the crocodile clip to 20 centimetres and repeat and keep doing that 30 centimetres, 40 centimetres and so on. Afterwards, you'll take those two readings of current and voltage and calculate the resistance. Remember, resistance is current divided by voltage or potential difference. You then plot a graph of resistance against the length of the wire and you'll find that they're directly proportional. So in other words, as you increase the length of wire, then there's more resistance. You can also investigate the resistance in different components, and you need to know what that would look like in a resistor, a filament bulb and a diode. You'll set up a circuit as shown here. This time you need to use a variable resistor, and that's a resistor that you can change, so you can change the current that's flowing through the circuit. The component you will place here, so in this example it's a resistor, but it could also be a bulb or a diode. You will then change the resistance using this variable resistor, and that will change the current and the potential difference. And you'll take two readings, one of the current, one of the voltage, and do that twice to get an average. You then will plot a graph of current against voltage for each of the 3 components. This is what the graphs look like. You do need to know the shapes. So for a normal resistor, current and voltage are directly proportional. For a bulb, the graph actually curves like this, and that's because as a bulb gets hotter, it's harder for the current to get through, so resistance increases and the current starts to decrease. A diode looks like this because current only goes in one direction, so it won't go the other way. You need to know how voltage, current and resistance behave in series and parallel circuits. So in a series circuit, the current is the same everywhere all the way through. So say for example here, it was 5 amps, it'd be 5 amps here, 5 amps there, all the way through. The potential difference though is shared. So for example, this 6 volt battery would share through these components, if they were both the same, equally to be 3 volts and 3 volts. If that was bulbs, it would show that the bulbs will get dimmer. The resistance is just added up. So if you've got 2 resistors there, you just add it up. So the resistance increases the more resistors you add. That's in a series circuit. In a parallel circuit, the current is shared, and it's shared at the junction. So junction is like here, so the current will split and then join up again on the way back. The potential difference this time is the same. So, for example, here, a 6-volt battery would provide 6 volts here, 6 volts here, which means if you added bulbs, they'd all be the same brightness. This time, the total resistance is less than the resistance of the smallest resistor. So the more resistors you add in a parallel circuit, the lower the resistance. When a wire or anything gets hot, there is more particles vibrating inside the wire, which means it's harder for the current to get through. So increasing the resistance decreases the current. There's two devices you need to know about. Light-dependent resistors, or LDR, they depend on light. When it's really bright, there's less resistance, so more current can flow. And these are used in things like night lights. Thermistor, these are dependent on temperature. As the temperature increases, this time there's less resistance, so more current can flow. And that's how a thermostat works. You also need to know how to investigate resistance in series and parallel circuits. So in a series circuit, if you add resistors in series, the current will go down and the total resistance will increase. If you add resistors in parallel, then the current will increase, and that's because the total resistance decreases. So the more resistors you add, the smaller the overall resistance. If you pause the tutorial and try these key questions. Okay, so in the first circuit, this is a series circuit. The components are in series. If you had to find the voltage for here and here, then it would be split from the voltage here, which is 6 volts. So this would be 3, this would be 3 volts. This is a parallel circuit, so this time the voltage would be the same. So where it's 6 volts here, it'd be 6 and 6 here. Define the following. So current is the flow of electrical charge. The potential difference or voltage is the force that pushes that charge. Resistance is anything that slows down the charge. And Ohm's law is resistance equals potential difference divided by current. In summary, we've looked at electric circuits and 3 practicals.